verifiable computation becomes cheaper and cheaper, people are going to use it in more context. Boundless is ready for that future to serve as a elastic compute cloud for every need, not just on-chain, but everywhere, on your phones, on your browsers, and every application that verifiable compute can make your lives better, safer, and faster.
You also had a very sort of viral signal campaign. It was great because you had people who were not proving and people who were proving, but you found a way to really combine the two.
Boundless is designed as a marketplace, but it's designed with the intention of being a marketplace for ZK.
I can be a developer on Ethereum that uses the Steel product that you guys have built to leverage the Boundless ZK marketplace. And I can be Solana developer, Avalanche developer, Cardano, whatever, right?
We want to be in every place and we want to be neutral whilst doing it. So from that perspective, a bet on Boundless, a bet on our growth is actually a bet on all ZK growth.
Cool, welcome to another interview series for Korea Web3 Embassy. I'm Daniel from Kintsugi.
I'm Ko at UNLA Blockchain Company.
Yeah, quickly about us, Korea Web3 Embassy is a consortium of 3 organizations, Kintsugi Technologies, UNLA Blockchain Company, and FactBlock, the host of KBW. Kintsugi helps plant embassies in all parts of the world. But I think what would be really interesting, as always, is to hear about UNLA Blockchain Company and where we are today, and the fact that we have a proprietary Tier 2 ISO 27001 certified data center that we're running infrastructure from. If you could share a bit about that.
So, UNLA Blockchain Company is founded 2022, is a subsidiary of UNLA. UNLA is a #1 cybersecurity company in South Korea, which shares like more than 60% of the endpoints. Our antiviruses and our UTM devices and firewalls are installed all over the places, including governments and commercials. So UNLA Blockchain Company also owns a part of the UNLA data center in this very old building, and it is a Tier 2 data center with the certified ISO 27001.
Cool, yeah, and I think maybe you don't want to say it, but probably OnLab is one of the most secure places in Korea. And we just had a tour of their sort of war room and where all the North Korean traffic gets stopped. So we're very safe here. Cyber is safe. But yeah, I'd love to introduce you to Shiv, the CEO of Boundless, and also formerly part of like the RISC Zero ZKVM team. If you could just briefly introduce yourself and then talk a little bit about Boundless and then maybe also its connection to RISC Zero, that'd be great.
Yeah, firstly, super glad to be here. Amazing tour, amazing facilities. Always great to see everything in action. So I'm Shiv, I'm the CEO of Boundless. This is Daniel said, formerly of RISC Zero. RISC Zero, of course, invented the ZKVM and all its applications in blockchain. Boundless takes that mission forward, bringing that technology to every chain, every builder, every application in every context. Yeah, we're super happy to be here and looking forward to this conversation.
Cool, yeah, and I think that you have like such an extensive history also in like the cloud security, right? I think Ko, you said you also have been like in mobile security. I think you literally built this building too, right?
Well, I was in the team of the building this task force, and I was one of the member who designed and all the facilities in the QA rooms and all the test facilities and so on.
So yeah, we're big brains all over here. So
I mean, it's interesting because I'm from Seattle. The code name for Seattle is Cloud City because it's the home of Amazon, AWS, Microsoft, Azure. Google Cloud has a huge presence there. Meta's infrastructure team is based in Seattle. Robinhood's infrastructure team is based in Seattle. So in a lot of ways, Seattle is home to the infrastructure for the Northern Hemisphere and the Western world in a lot of ways. So, you know, it's very, very good to like work with like partners who understand those challenges and understand the sort of level of maturity that is required to build global services at scale. And not just, small demos, but rather like build it in production, keep it in production, keeping it secure. So yeah.
Yeah, and we're really happy as the Korea Web3 Embassy to be like your partner in Korea and all that. Like, I think really the Korean Web3 Embassy is like the best of all these worlds, right? We have like the most secure location in Korea, proprietary data center. We have FactBlock, who's the host. I think they just had 28,000 people like almost 10,000 more people than last year attend the actual conference, and then we've been helping set up this infrastructure. But maybe if you could talk a little bit about like what a ZKVM is, how RISC Zero was so important in that, and then obviously the big thing, Boundless, and how that is going to affect all of us.
Yeah. So ZK has been around for like 30, 40 years. So it actually predates blockchain industry by quite a fair bit, and actually was studied pretty much at the same time as AI was. ZK is primarily a security product. Everyone thinks it's about scaling blockchains and stuff, but like primarily it was studied for its security properties. The most famous use case is how do I share part of the information to someone without giving away everything about my sort of information store. As an example, like I just need to prove to you I'm above 18 to go into a bar. I don't need to give you my driver's license, which has my address, my hair color, my eye color, and every single other detail about me. How do I just expose the details that I want? So that privacy first approach. And for the longest time, ZK was studied under that premise. But that's ZK the field. If you ask me the question as an engineer, how do you ZK? Or how do you write a ZK program? The way to do that was to write circuits. Very low-level languages which required a lot of in-depth knowledge. There were maybe like 200 people who could do it and another 200 people who could audit it in production. So 400-person industry doesn't really like grow at all. And that's really the way in which even blockchain started adopting it. Starkware and so on, when they started looking into ZK, they were still writing circuits. And that was mostly kept in the upper echelons of people with PhDs. Most people didn't understand its application. It didn't find product market fit. The interesting thing is Jeremy, who was the co-founder of RISC Zero, he's a self-taught mathematician. He never went to college, just sort of like went to high school and then decided to teach himself enough math, computer science, to build multiple startups. I think his previous startup, he sold it to Intel. He was uniquely in a unique position where he knew enough about compilers, hardware, mathematics, computer science, and GPU tuning to put all of this together and say, how do I build something that makes ZK accessible? That's what the ZKVM is, ultimately. It's a way for you to represent your ZK program in a high-level language, in this case, Rust, very easy to learn, completely open source, anybody can pick it up. So you can now write a ZK program in Rust, and it outputs like a circuit for you, a custom circuit that you can use for your applications. Usually, when you do this kind of abstraction, the trade-off is performance or something else, right? Like when you abstract something, it's like you lose something in the trade-off, but not in this case. It was a strictly better improvement, which is very rare. The reason for that is the ZKVM turned writing circuits into a platform, a stack. And what that means is now you have multiple points of attack to improve the stack, make GPUs go faster, make the interface between your code and the GPUs go better, write better proof systems, solve something at the math level. So every single place people could make things better. So over the last 2-3 years, we've become like around 2000x faster than where we were. That's amazing, and that actually means that handwritten circuits are now slower than circuits written on ZKVMs. A great analogy for this is manual transmission versus automatic transmission. When automatic transmission actually came in, it used to be less efficient than manual. So people use it, but now it's not the case. Even in F1 cars, people just use automatic transmissions. So it's that sort of thing where like the technology has gotten way better than handwritten circuits. So much so that Polygon has actually abandoned its ZK EVM project, where it poured in like hundreds of millions of dollars. They basically decided this is the way. So RISC Zero, of course, was the first ZK VM. We got there, we open sourced it, and we gave it away to the world and said, like, here's how you do this. So almost immediately, like, people started like either using it or copying it and building their own ZK VMs. 20 months ago, there was one ZK VM. 19 months ago, there's 2. Yesterday, there was 38. God only knows how many more are coming. So that's great. Now there's proliferation of the standard, and we were into building standards. How do you actually deliver ZK VMs on-chain to users is the next real problem, and probably the only part of the problem that is monetizable as a business. That's what Boundless is. Our ability to deliver ZK VMs or ZK programs or off-chain computation or your ZK, or really just satisfy your ZK needs in every context is unique because we are completely decentralized. We are as decentralized as the chain on which you operate, which on Ethereum is as decentralized as you can get. Because of the tokenomics and the market mechanics that we have, we drive costs down. During mainnet beta, which is sort of our version of testnet where we were using real funds, because people started using the token so much or speculating on the token or using the token as a subsidy, the P50, the median price of all proofs was $0.
Wow.
The P90 of all proofs was $0. The P95 was also $0. I don't think that is going to happen on mainnet, but what that does indicate is there's going to be a massive subsidy effect. So if a ZK program used to cost you 50 cents, it's going to cost you 5 cents now. And that's amazing because that means you're going to use more and more of it. In economics, there's this argument called Jevons paradox, which talks about high utility assets like coal. Previously, it used to be quite expensive to mine coal, and coal was a very valuable commodity. But something changed, and coal became much more available. So the price of coal actually went down drastically. Everyone thought what would happen is people would use coal less, or the industry would shrink. The opposite happened. People started using more and more coal. The steam engine was invented. The modern technical age, the industrial age, started because coal prices dropped. Same thing happened with computers. When cost of computing went down, everyone thought, oh, computers will just, the industry will shrink. Instead, we put computers everywhere. And usage of computers increased. Same thing is going to happen with verifiable computation. As verifiable computation becomes cheaper and cheaper, people are going to use it in more contexts, use it all over the place. Boundless is ready for that future to serve as a elastic compute cloud for every need, not just on-chain, though product market fit on-chain is the highest right now, but everywhere, on your phones, on your browsers, and every application that verifiable compute can make your lives better, safer, and faster.
I have a personal story that I think exactly describes not just on-chain. I think I may have told you in the past, I used to work at a bioinformatics lab, and we were using FHE, fully homomorphic encryption, but then we were sourcing gut bacteria data from different labs. And we needed to put it all in a pile, encrypt it to do the FHE, but we didn't trust each other because it was expensive. And so we used ZK to basically prove things about the data that we're providing. And we had to write grants to get money to run this ZK and FHE, which was expensive, and it took a week. If we had, this was almost 9-10 years ago, if I knew that there was Boundless, which allowed us to get, as you were saying, really cheap computational power that could do ZK, then of course we'd be using this. And I think what I'm really excited about is to see a lot of these real world use cases that don't necessarily have to be on chain, that you can see Boundless being ubiquitous and used everywhere. So that's really exciting. Yeah. Can you talk a little bit about the mechanics of Boundless and sort of, I think you guys have some really interesting analogies of what Boundless is, and also maybe how difficult it is to get that, right? Because it sounds easy, but clearly it isn't, right?
Yeah. I think building a elastic compute service it's hard enough even if you want to do it in a centralized way, right? If you want to rebuild AWS or Azure or Google Cloud, I can tell you it's pretty hard. They've put in few $100 billion in to make a $1 trillion business. So there's years of learning that they have there. It is even harder to build it in a decentralized manner. But from our perspective, our on-chain customers would never use a centralized service. They do not want to have a single point of failure. If you want the snarkification of Ethereum, which is basically when you ZKify Ethereum, and instead of the validator sort of computing everything again and again, they just use proofs instead. What if I told you all of it ran on AWS? You'd be like, yeah, well now let's just move to AWS, then what's the big point, right? So we needed a service that could function even if the Boundless team vanished. And there's actually a funny example here. During mainnet beta, because we branched off of RISC Zero to become our own entity, some of our assets, digital assets like our domain name and things had to be handed over. There was a little bit of paperwork issue, and boundless.xyz went down. So the website went down, all our AWS services, all our endpoints went down. So we were not in the network at all. Nothing happened. That is the full proof of decentralization, that the team was completely disconnected from the network and it kept up at 100%. That was always the dream for us, and we were so happy that it happened. I actually wrote a paper about it called Chaos Monkeys, which is Netflix's program for running a program that just like unplugs different services to see if there's graceful degradation. And we were very happy to see that. But the design for that actually takes a long time. It took us a lot of back and forth within the team, with experts across the world that we trusted. We have Dan Bonet, who's like an advisor, Patrick O'Grady from Commonwear, who used to be the head of engineering at Avalanche. We have a lot of people with whom we sort of like exchange ideas. All of them were taken aback with our approach because what we ended up doing was taking proof of work, which is Bitcoin's mechanism for managing rewards, epoch rewards, and so on, and ZKifying it. There's actually a funny email that Satoshi sent where he said like, oh, I think ZK would be like super applicable here. I just don't know anything about ZK. So it's been waiting for that moment, and we're so happy to bring it to life. So what proof of verifiable work actually does on our network is there is a programmatic mechanism baked into the protocol for the fair distribution of epoch rewards based on the amount of compute you provide to the network. That's completely different from Bitcoin. For example, in Bitcoin, there is a one winner take all per epoch. So what that means is there's a competitive element. Whoever wins, they win. What that actually means in reality is like if you don't win for a while, you think you don't have enough compute resources, you fall off. And you've seen that in like 10 years or 8 years ago, people used to mine Bitcoin in their rooms because they had like a little machine and they'll turn it on and it'll mine something. Now it's basically impossible. We're up against like gigantic data centers with like unlimited cheap power and computing resources. In proof of verifiable work, what we are able to do is we are able to see how much work everyone brings in. Let's say, Daniel, you do 10 times the work that I do, you get 10x the rewards that I do. I don't get zero. I just get less rewards. But the interesting thing is, if so many people are interested in getting those rewards, the value of the reward that I get is also higher. So there's a space for a large player, a medium-sized player, a small player, and also some kid in Germany sitting by himself, mining ZK proofs, which is what happened during our mainnet beta, where we had a German high schooler who was like top 5 in the leaderboard for the longest time. I won't give out any numbers or names, but we're pretty sure we funded his university education in mainnet beta, which is fantastic, and we want to see more of that. So in a lot of ways, Boundless is designed as a marketplace, but it's designed with the intention of being a marketplace for ZK. So a marketplace that understands what is being sort of traded on it is the strongest kind of marketplace. Otherwise, anybody off the street could have designed a marketplace. Take supply, take demand, smash is a marketplace. But if the market actually understands what is being traded by different parties and is optimized for that, it works really well. The last thing I'll add here is my own personal experience for the past 10 years has been in markets. At Amazon, at Lyft, at Grab, which is a Southeast Asian rideshare company, Coinbase, and so on. It's very important to understand if your two-sided marketplace is supply-driven or demand-driven. Ours is supply-driven because it is harder and more work and time-consuming to get a large prover online than it is to get like someone who is comfortable with software to just sort of like start using your service. So from that perspective, it is also the kind of tooling and everything else that we built on the supply side that makes us not just a competitive, but a superior product to anything else that's out there.
I think it'd be great to kind of go through like the phase of how Boundless came to light, right? I mean, you guys TGE'd recently, day one listings on like the top Korean exchanges and a lot of global exchanges, Coinbase, Upbit, Bithumb. But you also had a very sort of viral signal campaign, right? And then, right, a lot of these people were, right, it was great because you had people who were not proving and people who were proving, but you found a way to really combine the two. And right, it's not everyone who supports Boundless needs to be a prover, right? Maybe if you could talk a little bit about that and like, I think like the brilliant way that you sort of married all the interests.
Yeah. Firstly, I can't take any credit for it. I think a lot of it is pretty left brain, my weak spot. Our core marketing team is hot stuff, if I can say it. They really understood the challenge. once you understand what the problem is, it's way easier to craft a solution. They understood the assignment, as it were, and said like, okay, yeah, this is what we want to do. It didn't make sense to me initially, and then because there were a lot of ifs and buts, but I think the quality of the team actually shone through. The Signal campaign essentially was our take on what should we didn't want a testnet. Every testnet in crypto has sort of become a joke where people just do games to sort of farm attention. I think we had a broader mission around like, we want to educate people about ZK. We want to educate people about privacy, about security, why it's important. Why is ZK important to your project on crypto? So if you're, and people do have like a favorite crypto project or whatever, right? They're like, I'm on Ethereum and this is the project I like, or, I like this trading app or whatever. Why is it important for your favorite app to adopt crypto? That's something we wanted people to understand and learn. The Signal campaign actually provided us that opportunity where we said, hey, like participate in our campaign and ask for your chain to be proven. And we collected like over $1 million in Ethereum donations to prove Ethereum, prove Solana, prove Base, all of them in serial order on Boundless. The interesting thing is when we talk about proving Ethereum, there is one aspect of it is where you sort of do a state transition proof. We also went for full consensus proofs, which nobody had tried before. Because somebody has to write the client to actually like get all the consensus proofs done. People generally write light clients, which are easier to do, but have drawbacks because by definition they're lighter. They do a random sampling of like a few nodes. There's no economic security and so on. A full consensus proof is much, much stronger. And the other one is cost. Such a large proof would have taken money. Boundless was doing it for free for most of mainnet beta, which is amazing. What these full consensus proofs actually allow you to do is to take proven state of Ethereum anywhere you want. You can take it to Solana, and now you have all of Ethereum state available to you for you to verify. You can take it off-chain. You can take it in smaller devices anywhere. Now, let's say I also do Solana proofs. Now you have full state of Solana wherever you go. It starts breaking into lots of interesting markets with oracles, with cross-chain bridging. The entire interop industry opens up all over again. When you think about it, a lot of chains are incentivized to become better chains. They aren't incentivized to be better at interop because they don't care.
Unless they want to like steal liquidity or users from others, and yeah.
So people are generally like more incentivized. That's just why the bridging industry is mostly taken as stagnant. It's like, this is what bridging is, so I'm going to get better than this. Or this is what oracles look like, this is what, we don't need to do anything better. But ZK oracles and ZK bridging has always been on the horizon. We wanted to show with a mainnet beta, so a beta product, how possible this is. And a lot of interest has been generated. A lot of folks with expertise, either in bridging in oracles or entities that are already in that business are working with us to build the next generation of products, which is how it should be done. If we are an infrastructure layer or an infrastructure company and we modernize the infrastructure, users should feel the benefit of it. And that's coming. That makes me really happy. Like if we had done all this and, done some token stuff and like, I bought a yacht, you bought a yacht, everyone just goes off yachting. And the customers are just left, or the users of crypto are just left with like, nothing really changed. That's not healthy. And also not how Seattle companies do it, right? Like, I have a reputation to uphold for Seattle where we build infrastructure that changes the world. It's important to me that I am putting all my energy. We were just talking about how little sleep I get in KBW. Put all that energy towards productive, useful work. I'm glad to be paid and makes it may be successful, but only if that makes everybody else using these products also successful. One of my key focuses as a leader, I guess, is companies that build atop Boundless, I want them to be successful businesses, not just successful ideas that just snap and just go back, but rather like actual businesses that grow.
Can you talk a little bit about that, right? So we know that Boundless is a marketplace for compute, for ZK. Chains can use them, dApps can use them, like wallets can use them. What does it look like? What are the type of, let's say there are developers out there that are watching this and they want to get involved somehow, right? Besides, just holding the token and staking it or something like that. Like, what are some of the example applications that you see or would want to see built on Boundless?
Yeah. So one of the key things that we've been doing as we build Boundless is building up a set of libraries for people to use. If you want to be an Ethereum developer and start building smart contracts and things, whilst everyone would advertise as very simple, what's very simple is hello world. The next step is not simple. You need to understand storage slots and how Ethereum, keeps its history and how you access all of this. It's a bit like learning the internals of Ethereum to build on Ethereum. We have a library called Steel that abstracts out all of this for you. So think of it like a database driver. You'll just like gets and puts and you don't really care about anything else, which is how it should be. Once you have that, once I've abstracted out the chain and you're allowed to use Rust, now your only dependency is learn a little bit of Rust, which I think is an acceptable sort of ask from a developer. Once you're able to do that, Bob's your uncle. You can do whatever you want. You can access Ethereum state. So you can be like, oh, for this user, get me this information. Here's some computation that I do and put it back. And this is extremely cost efficient. And you can prove this transaction on, and there is no limit on how big this computation can be. You can write pretty much any DeFi application. Because if you actually zoom out, all DeFi applications are the same. Look at some personal information, look at some global information, apply some algorithm, then you change state. That's it. That's what all DeFi is primarily. Now you're able to do that, deploy it, and run it on smart contracts. The other interesting thing is if you already have smart contracts out there, Steel helps you run the smart contract inside a ZKVM with one line changes. So that's like the power of a ZKVM, right? You can just implement any sort of DeFi system. I think if you are new to writing Web3 programs, I'd ask you to do very simple swaps. Once you do that, you're like, oh, you'll get confident that like I can do this. Just that primitive itself allows you to do a lot of interesting things. Yeah.
I see. So if I'm understanding it correctly, I can be a developer on Ethereum that uses the Steel product that you guys have built to leverage the Boundless ZK marketplace. And I can be Solana developer, Avalanche developer, Cardano, whatever, right? And do that. Wow, that's really...
Yeah, I mean, another interesting thing to note is like Stellar, for example, just launched its RISC Zero verifier. And they demoed the first ever ZK program on Stellar in Rio. Think about what that unlocks. Stellar doesn't have like a full compute capability. They have like a limited thing I forgot what it's called. But now you can write any program, anything. Like it's Rust. There's no limit to what you can write. You can write any program and have that executed and put the results of that execution in Stellar. That's amazing. So an L1, XRPL, all of these like other L1s that have limited functionality for a reason can now have an entire execution layer. Like you were asking about metaphors. Like the simplest metaphor for me when I talk to my friends in Web2 is AWS's stack is possibly the most commonly used stack for building applications. You have DynamoDB and then you have EC2. You also have other things, but like primarily these are the two things that, on which you build your application. Blockchains are your settlement layer. They are your DynamoDB. We've always lacked an execution layer. That's what Boundless is. Now here's something that is a little bit more in the MBA range of the conversation. When you actually break down AWS's sort of revenue numbers and so on, you'll see that DynamoDB or like their database products account for 9 to 12% of their revenue at a 30-40% margin. Compute or EC2 and all its queues account for 50% of all its revenue at 50 to 60% margins. What that means is when people build applications, most of the billable actually goes into compute. Now, if anyone here runs infra, and I'm looking at you, of course you do, when you go to scale and when demand spikes or your traffic spikes, your database usage is on a linear curve. Your compute usage is on an exponential curve, which means as we start scaling, this is what scaling looks like. You need more compute. And the ability of Boundless to absorb more and more GPUs or compute and constantly scale allows us to be that layer for everybody. We're built for the future. Our tagline really is like being at internet scale. That's what that means.
Can you talk about, and obviously like we've been really excited at the Korea Web3 Embassy to to start having some of these GPUs inside those server rooms, to start running provers, and like there's a staking component, right? Like, can you talk a little bit about that for, I mean, people who might hold Boundless ZKC tokens and then want to stake it and what that means for them?
Yeah. So essentially, we have an inflationary token that emits rewards every epoch. An epoch currently is 2 days. It can be changed with our governance model, but like 2 days is like pretty well established. A percentage amount of those tokens go for passive stakers. Something like 25%, I think, is the current number. Where if you hold the tokens and you just want to, stake them and do nothing really, 25% of the emissions go for that. 75% of the emissions are for active provers, people who are actually participating, in the proving activities. The way this works is, if you are a prover, you set your own ceiling on your rewards by staking. So if you stake like 100 tokens, like I've forgotten what the ratio is, maybe it's like 10% or 20%, the amount of compute you provide, you get rewards for that, and that hits a ceiling of how much you stake. So if you bring more compute power, you should be staking more, so you can claim more of the tokens, essentially. This allows you to, not just be a participant, or also like be a participant over a consistent period of time. So there is a way for you to sort of be sticky, for the platform to be sticky.
Have skin in the game, and got it. Yeah, what would be like a way for people who are not provers to kind of be excited about Boundless and ZKC? Like, obviously, yeah, you can hold the token because you believe that, compute's going to be everywhere. There's going to be so many customers that are going to use it, right? As you said, like, you have no problem with demand, right? There's so much demand for this. How would you communicate like the excitement about like holding the token, for example, for people who are not technical or provers?
Yeah, so I think as much as like I'm not an investor or financial advisor, I'll talk a little bit about what ZKC actually represents. One of the reasons why RISC Zero and Boundless, we had like a friendly split, is that we realized if RISC Zero was the company behind Boundless, everyone would think Boundless's potential is defined by the technology developed by RISC Zero. We were pioneers. We invented the ZKVM, but we are also humble. We realized we sparked a revolution, and we can't compete with 1,000 teams. And that's good. That's good that there's 1,000 teams, but there's no way we are going to be the best team forever. By making the split available, what it actually does is Boundless is now in a position to absorb ZK development across the space. We want to be multi-ZKVM. We want to absorb the next big innovation in ZK. We want to be in every place, and we want to be neutral whilst doing it. So from that perspective, a bet on Boundless, a bet on our growth, is actually a bet on all ZK growth, a bet on all blockchain growth. That actually means there is no upper limit to our growth potential. But think about it this way. There is, like I said, if the breakup of like gas and whatever you see for like compute on chains, if you just capture that in itself, it's hundreds of billions of dollars of compute that can be moved off chain, made much cheaper. But then again, once you're doing that, you're going to be doing a lot more. So from somebody who maybe isn't like, super technical, what I would say is, in a world where all your web services, from your Uber to your Tada to your Kakao, and all of these things are being run in a Web3 manner, my bet, at least as the CEO of Boundless, is that a lot of it is going to be run on infrastructure that goes through the Boundless network. And all of this is united by a token like ZK Coin. And that's really my personal bet or professional bet on this. So yeah, that's a reason why a lot of people believe in the ZK revolution. This is also the year of ZK. A lot of like ZK companies are coming out of the woods, which is great. Even at KBW, every ZK team I'm talking to, they used to write circuits. They're building ZKVMs, and I give them a high five. Everyone is very surprised sometimes, like how friendly I am with like other ZK teams. I'm like, yeah, this is what
all will be converging onto the Boundless platform.
That's exactly right.
Wow, thank you so much. It's wonderful. Thank you, Shiv.
Thank you.